Okay, so I think the key for these is to really make that table that I talked about in the note page. So let's think about that. So what are the outcomes? And I like to list those first, and I like to be organized. So you can get 2 heads, 1 tail, and 1 head in either order, and 2 tails. So really those are our different things we care about. And the probabilities for those are, okay, so those are events. Let's get the probabilities. The probabilities are if you get 2 heads, that's a half times a half, so that's a quarter. That's the same for 2 tails, so we used up a half, so this is a half. And it's nice to check that this is worth 100%. That's really nice to do. Okay, now the next thing we have to get is, let's get the payoff. And this you just have to make sure you read really carefully. So go back to the words, and since there's 2 different people, we got to think about the payoff for A and the payoff for B. Okay, so let's see what happens. If we have 2 heads, A wins $5 from B. So 2 heads, A wins 5, but B's paying it, so B has to be minus. Oops. That's silly, Miss Brady. That has to be minus 5. Okay, let's see. If 1 coin lands heads up, then B wins $1 from A. So B would win $1. So plus $1, which means A would have to pay $1. And if both coins land tails up, then B wins $2. So B would win $2, which means A would have to pay $2. Okay, now let's get the expected outcomes. Let's do A. So A is 1/4 of plus 5 plus 1/2 of minus 1 plus 1/4 of minus 2, which is 5/4 minus 1/2 minus 2/4, which is minus 1/2. So A's up 1/4. And if you did B, B would be exactly the same thing, except B would be the flip of what A was. So 1/4 minus 5 plus 1/2 plus 1 plus 1/4 plus 2. And so it would turn out when you add these together that B would be down 1/4. And so we say that this game, because now the new question is this a fair game? And that answer is no. How come? Because who wants to be B, right? It would be fair if over the long run, A and B weren't losing money from each other or gaining money from each other. Okay? Okay, so let's now look at the second one, and we're going to do the same strategy. We're going to make the table first. And I even put stuff in, even if I usually make the table first because it's just easier to think about the outcomes. Okay, so there's 5 red and 3 blue, and we're checking 3. Okay, so what's our choices? Let's just think. Red, blue, and we'll just be organized. Okay, so we can have 3 and none, 2 and 1, 1 and 2, or 0 and 3. And no matter how I need to pay out, those are my choices. Okay? Okay, so I've got 1, 2, 3, 4 outcomes. Okay, let's get the probabilities. So this is, how are we going to count the probabilities? You're doing it without replacements. So you can't use binomial theorem, so we're going to use combinations. There's other ways to do it, but I think combinations is the most straightforward. Okay. So let's get the probabilities. Okay. Okay, so we're going to have, out of the 5 reds, we're going to choose 3. We're going to times that by, out of the 3, we're going to choose none. And we have to divide that by an unrestricted choice. So that would be out of the 8, choose 3. And when I get the probabilities, it's going to be pretty easy. I'm going to write them all first. I know the denominator is all the same. I just have to change the numerators. So now I'm going to choose 2, 3, choose 1, and I can just march this one down. And I can march this one up. So you could do this by hand or get the calculator, but if you get the denominator first, that's usually easier. So I typed that on my calculator. You can pause if you want to do it, but that's 56. And I did this one on my calculator too. 5 choose 3 is 10. But let's think about which ones we don't need our calculator. So choosing nothing out of 3 is 1. 5 choose 2 would be the same as 5 choose 3, because if you're picking 3, you're not choosing 2. So this is 10. And 3 choose 1 is 3. And this would be 5 choose 1 would be 5. 3 choose 2 means you're not choosing 1, so that's 3 again. And this would be 5 choose nothing, that's 1. And 3 choose 1 is 3. Oh, sorry, 3 choose 3. 3 choose 3 is 1. Okay, so let's see what we got then. So this is 10, this is 30, this is 15, this is 1. And it's nice when you add them, you can check. So I've got 10, 40, 55, 50, I've got 56 out of 56. So we know we counted those right. Okay, now let's get the payoffs. Okay, so what does it say? $10 if the marbles are not the same color. So that would be here. And we will get, these are not the same. And then $20 if they're exactly 3 red marbles. So that's this one here, which means no payoff here. And now we just have to times. And it's actually nice if you don't reduce the fractions, because it's going to be easier. We'll times here. So when I take my payoff, it's going to be, I'm going to do up here. Okay, so it's 20 times 10 plus 10 times 30 plus 10 times 15 plus 0 times 1, whole thing over 56. And when I used my calculator, I got 1161.